Q6633. During flight in an airship, vertical equilibrium is established when A. Pressure height is reached. B. Buoyancy equals airship weight. C. Buoyancy is greater than airship weight. The correct answer is B. During flight in an airship, vertical equilibrium is established when the buoyancy of the airship equals its weight. Vertical equilibrium refers to the state in which the upward buoyant force acting on the airship is equal to its downward weight. This balance of forces allows the airship to maintain a stable altitude without ascending or descending. The buoyant force is generated by the displacement of air by the airship. It is directly related to the volume of air displaced and the density of the surrounding air. The weight of the airship is determined by its mass and the force of gravity acting on it. For vertical equilibrium to be achieved, the buoyant force must be equal to the weight of the airship. This means that the airship's buoyancy is supporting its weight, counteracting the force of gravity. If the buoyant force is greater than the weight of the airship will experience a net upward force and start to ascend. If the buoyant force is less than the weight, the airship will experience a net downward force and begin to descend. Therefore, during flight in an airship, vertical equilibrium is established when the buoyancy of the airship equals its weight. Q6635. If an airship is either light or heavy in flight, the unbalanced condition must be overcome. A. By valving air. B. Aerodynamically. C. By releasing ballast. The correct answer is B. If an airship is either light or heavy in flight, the unbalanced condition must be overcome aerodynamically. When an airship is light, meaning it has excess buoyancy or insufficient weight, or when it is heavy, meaning it has insufficient buoyancy or excess weight, the unbalanced condition needs to be corrected in order to maintain stable flight. To overcome this unbalanced condition, aerodynamic means are employed. Adjusting the control surfaces and the angle of attack of the airship can help generate the necessary aerodynamic forces to counteract the unbalance. In the case of a light airship, increasing drag or reducing lift can help decrease the excess buoyancy and bring the airship back to a balanced state. This can be achieved by adjusting the control surfaces, such as the elevators or rudders, to create more drag or reduce lift. On the other hand, if the airship is heavy, increasing lift or reducing drag can help increase the buoyancy and restore balance. This may involve adjusting the control surfaces to generate more lift or reduce drag, or utilizing engine power to increase airflow over the lifting surfaces. Releasing ballast, as mentioned in option, is one specific method of adjusting the weight of the airship to achieve balance. However, it is not the only method, and aerodynamic adjustments play a crucial role in overcoming the unbalanced condition. Therefore, when an airship is either light or heavy in flight, the unbalanced condition must be overcome aerodynamically. Q6636. An airship descending through a temperature inversion will A. Become heavier as superheat is lost. B. Show no change in superheat as altitude is lost. C. Become progressively lighter and increasingly more difficult to drive down. The correct answer is A. An airship descending through a temperature inversion will become heavier as superheat is lost. A temperature inversion is a phenomenon where the temperature of the atmosphere increases with altitude instead of decreasing, which is the typical temperature lapse rate. In a temperature inversion, the air at higher altitudes is warmer than the air below it. When an airship descends through a temperature inversion, it encounters warmer air as it moves to lower altitudes. The superheat within the lifting gas of the airship, which is the difference between the temperature of the lifting gas and the ambient air temperature, will decrease as it comes into contact with the warmer air. As the superheat decreases, the lifting gas becomes cooler and contracts, resulting in a decrease in volume. This decrease in volume leads to a reduction in the buoyant force exerted by the lifting gas, making the airship heavier. Therefore, when an airship descends through a temperature inversion, It becomes heavier as superheat is lost. 6637. The four principal forces acting on an airship in flight are A. Buoyancy, drag, gravity, and thrust. B. Lift, drag, temperature, and pressure. C. Gravity, compression, buoyancy, and equilibrium. The correct answer is A. The four principal forces acting on an airship in flight are buoyancy, drag, gravity, and thrust. 1. Buoyancy. Buoyancy is the upward force that supports the weight of the airship. It is created by the displacement of air by the volume of gas, such as helium, contained within the airship's envelope. 2. Drag. Drag is the resistance encountered by the airship as it moves through the air. It opposes the forward motion of the airship and is influenced by factors such as the shape and size of the airship, the speed of the airship, and the air density. 3. Gravity. Gravity is the force that pulls the airship downward toward the earth. It is the weight of the airship and all its components acting vertically downward. 4. Thrust. Thrust is the force generated by the propulsion system of the airship, typically provided by engines or propellers. It propels the airship forward and counteracts drag. These four forces interact to determine the motion and equilibrium of the airship during flight. By managing these forces, pilots can control the altitude, speed, and direction of the airship. 6639. What are the two most significant effects of positive superheat? A. Improved fineness ratio and pressure height. B. Increased static lift and decreased pressure height. C. Increased dynamic lift and decreased Ballonet capacity. The correct answer is C. The two most significant effects of positive superheat in an airship are increased dynamic lift and decreased Ballonet capacity. 1. Increased dynamic lift. Positive superheat refers to heating the lifting gas, typically helium, above the ambient air temperature. This temperature differential causes the lifting gas to expand, leading to an increase in its density. The increased density of the lifting gas results in increased dynamic lift, which is the lift generated by the pressure difference between the upper and lower surfaces of the airship's envelope. This increased dynamic lift allows the airship to achieve higher lift-to-drag ratios and improved aerodynamic performance. 2. Decreased Ballonet capacity. The ballonets in an airship are internal airbags or compartments that can be inflated or deflated to adjust the overall buoyancy of the airship. Positive superheat causes the lifting gas inside the envelope to expand, reducing the available space for the displacement of air within the ballonets. As a result, the ballonets have decreased capacity to compensate for changes in buoyancy. This can limit the airship's ability to adjust its overall buoyancy and maintain proper trim and control during flight. Overall, positive superheat enhances the aerodynamic performance of the airship by increasing dynamic lift, but reduces the flexibility of buoyancy control by decreasing Ballonet capacity.